Today we want to look at whether a given data set follows a particular distribution. So let's look at an example. A dice is thrown 120 times and the scores are recorded. The results are, 1 appears 21 times, 2 appears 28 times, 3 appears 15 times, 4 appears 23 times, 5 10 times, and 6 22 times. So is there evidence at the 5% level to indicate bias in the dice? So our null hypothesis would simply mean that the dice is not biased. And if the dice is not biased, then the probability of getting any score is 1/6. And our H1 is the dice is biased. That means the probability is not equal to 1/6. So let's look at a couple of necessities for our testing. One, we have to talk about our number of degrees of freedom, and that symbol there is nu, and nu is equal to the number of classes minus the number of restrictions. Now restrictions could simply be 1, that the sum of the observed frequencies is equal to the sum of the expected frequencies, and 2, and it's if we are estimating a parameter. Now in this case there is no parameter to estimate. Now if the dice is not biased, then and the probability is 1/6, and if we toss a dice 120 times, it's expected that to get any of the scores, the frequencies will be the same. So below here we have what we call a table of expected frequencies. Or what we call the EIs. And the data that is given to us is our observed frequencies. And that is our OI. Now, two things to note about our expected frequencies is that the expected frequency, our EIs, is equal to n times that's the total number of observations multiplied by the probability of x equal to xi, and all our expected frequencies must be greater than or equal to 5. If not, then we have to combine classes. Since all our expected frequencies are greater than 5, we do not need to combine classes in this case. Okay, so what we do now, we create a table with scores, our observed frequencies, and our expected frequencies. And then now we move on to calculate our chi-squared calc, and our chi-squared calc is our observed frequency minus the expected frequency to be squared all over our expected frequencies. So we do our calculations, and then the sum, the total here, which is our chi-squared calc, so your chi-squared calc is equal to the sum of I going from 1 to n of our observed frequencies minus our expected frequencies to be squared divided by our expected frequency. And our chi-squared calc is 10.4. Now this chi-squared calc is what we call our test statistic. Now the number of degrees of freedom, nu, in this case, the number of classes is 6 classes. And let's look and see what are our restrictions. Our restrictions, first, is that our sum of our expected frequencies must be equal to sum of the observed frequencies, that's 1. And we have not estimated a parameter, so there is only 1 degree of freedom. And that gives us 5. So total degrees of freedom is equal to 5. Now it's at the 5% level of testing. So what we do is to go to our chi-squared tables and look at our critical values to find the particular critical value for chi-squared of 5 degrees of freedom at the 5% level of testing. And that will give us 11.07. So we will reject H0 if our chi-squared calc is greater than 11.07. And since our chi-squared calc, which is 10.4, does not lie in the rejection region, okay, that is, since the chi-squared calc is less than 11.07, we do not reject H0 and conclude that the dice is not biased at the 5% level of testing.